Let's do a few examples where we do geometric series with sigma notation. Right, example 1. We have to evaluate this series. So what we do, we need to find our first term and our R, common ratio, right? So this means we have to substitute from 0 up to 15. So the first term is going to be where there's P, we put 0. And then the second term is going to be where there's P, we put 1. And then the third term is going to be where there's P, we put 2. It goes on like that till the last term we put 15. So it means we're adding negative 2 over 3. This would give us negative 2 over 3. And then plus 2, this will give us 2. And this will give us negative 6. To go on like that till this one, which will give us 9,565,938. Okay, so now we have our first term. A is equal to negative 2 over 3. R is equal to negative 3. And then number of terms is equal to 15 minus 0 plus 1. Remember, top number minus bottom number plus 1. So it's going to be 15 minus 0 plus 1, which is 16 terms. So meaning that n is 16. Sn is equal to, so sum of the first 16 terms, then our A is negative 2 over 3. R is negative 3 to the power 16 minus 1 over negative 3 minus 1. Then you can put this in the calculator. So the sum of the first 16 terms is 7,174,453,33. That's the answer there. Okay, let's do example 2. We are asked to find the value of m if given this series. So we're substituting where there's k, we put 1, we put 2, we put 3 up to m. Right, like this. Right, where there's k, we put 1, then plus. Where there's k, we put 2, and then plus. Where there's k, we put 3. It goes on like that till we put m where there's k. Then if we add all these terms in the series, we get 36,3. Right, this will give us 0,3 plus this one will give us 0,9 plus this one will give us 2,7. Goes on like that. Okay, to give us 36,3. Right, so from here our A is equal to 0,3, our R is equal to 3, the number of terms is equal to the top number minus bottom number plus 1, so it's m minus 1 plus 1, which is equal to m. Right, now let's substitute into our formula. What are we looking for? We're looking for m. Sn is equal to a r to the power n minus 1 over r minus 1. Then Sn is 36,3, so we say 36,3 is equal to a, which is 0,3 times r to the power n, which is going to be 3 to the power n minus 1 over 3 minus 1. Right, we're going to multiply both sides by 2 to get rid of this denominator. 3 minus 1 is 2, so we multiply by 2. We get 72,6 is equal to 0,3, and then 3 to the power n minus 1. Then divide by 0,3 on both sides of the equation. What do you get? 242 is equal to 3 to the power n minus 1. And then we add 1 on both sides of the equation. 243 is equal to 3 to the power n. Right? And then now 243 is 3 to the power 5. So 3 to the power 5 is equal to 3 to the power n. Therefore, n is equal to 5. And the number of terms, this value n is equal to m. So m is equal to 5. Done. Right, example 3 says, what is the value of p for which this series is greater than 68? Okay, so we're substituting 2, 3, 4 up to p to get a value that is greater than 68. So let's just do that. This means where this r you put 2, then plus, where this r you put 3, then plus, where this r you put 4, right? It goes on like that till we substitute p. Okay, let's just use an equal sign for now. We're going to use the inequality sign for our final answer. Let me just use an equal sign for now. 68 here. Alright, this is 6 plus, this will give us 12, plus, this will give us 24, and plus, it goes on like that. Our a is equal to 6, our r is equal to 2, and our number of terms is equal to p minus 2 plus 1, p minus 2 plus 1, which is p minus 1. Okay, because it says what is the value of p, so we need this. So number of terms is equal to p minus 1. Right, let's substitute into the formula. Sn is equal to a r to the power n minus 1 over r minus 1. Then we substitute. Let's use 68 is equal to 6, or r is 2 to the power n minus 1, then over 2 minus 1. 2 minus 1 is 1, so where this goes, we remain with 68 is equal to 6, 2 to the power n minus 1, like this. Then divide by 6 on both sides of the equation. 34 over 3 is equal to 2n minus 1. Then we add 1 on both sides of the equation. 37 over 3 is equal to 2 to the power n. Right now, how do we find n? We have to change this equation from exponential form to logarithmic form. Right? Remember, for logarithmic form, your exponent is your subject of the formula. So it becomes n is equal to, and then log, and then 2 is the base. So it comes here, and then the argument or the number 37 over 3, like that. Okay, right. Just check. Say 2 raised to the power of n, we go like this. 2 raised to the power of n is equal to this number. So 2 raised to the power of n is equal to 37 over 3. So it's fine. Right, put this in the calculator. N is equal to 3,62. Now, we need to consider this. It says, what is the least value of p for which the series is greater than 68? Right? So it means if we add 3 numbers, we are not going to get 68. Okay? If we add 3 numbers, because n is equal to 3,62, remember, n should be a natural number. So this number is between 3 and 4. So if we add 3 numbers, we're going to get less than 68. But if we add 4 numbers, then we'll get a value that is above what? Above 68. Okay. So it means our n should be equal to 4. We must add 4 numbers to get a value that is above 68. Let me just show you here. You can even check here. If you say 6 plus 12 plus 24, you'll get 42. So which is less than 68. You have to add the 4th term, which is going to be 48 here, to get what? To get 90. Okay, so for us to get a sum which is greater than 68, we have to add 4 terms. So that's why n is equal to 4 here. But what does the question say? What is the least value of p for which the series is greater than 68? So we want the values of the least value of p. And remember, we said that the number of terms is p minus 1. So it means this n is equal to p minus 1. So we say p minus 1 is equal to 4. Then add 1 on both sides of the equation, p is equal to 5. Okay, and it makes sense because we substitute 2 to get 6. We substitute 3 to get 12. We substitute 4 to get 24. And we must substitute 5 to get 48. And then these 4 will give us a value that is greater than what? 68. So It means P should be equal to 5.